Hello friends, I welcome you in lecture number 43 on basic statistics. In this lecture also we will discuss one more question on regression analysis which was asked in GTU exam in winter 2019. So here we are asked to find out the two lines of regression for the following data, and it is not specified that we have to use particular method like method of least squares. In earlier lecture we have discussed how to find out line of regression using method of least squares, but if it is not specified that use method of least squares, then it is advisable to use another method, because in method of least squares we require more work as compared to another method. So if you recall, in lecture number 41 we have discussed another form of regression line of y on x as well as x on y. We know that line of regression of y on x is given by y minus y bar equal to byx, that is regression coefficient of y on x times x minus x bar, and line of x on y is given by x minus x bar equal to bxy times y minus y bar, where this coefficient byx is having this formula. Byx was having different formulas. If we write down one formula, it was n times sigma x sigma y minus, here we have to write sigma x into y minus sigma x times sigma y divided by n times sigma x square minus sigma x whole square. And we are having another formula for this regression coefficient. We have shown in lecture number 1 these different formulas. It is given by r times sigma y by sigma x. Also it is given by sigma x minus x bar times y minus y bar divided by sigma x minus x bar whole square. We can use any of these formulas. In this lecture we are going to use this formula, but with some modification. This formula uses actual values of x and y. So if values of x and y are large, then it becomes tedious to find out all those summations, sigma xy, sigma x square and so on. So if we modify this formula, if we change the variables x and y to new variables u and v by this type of transformation, u equal to x minus some constant, v equal to y minus some constant, then we have one result which says that if we consider this type of change of origin, then regression coefficient does not change. That is, regression coefficient between x and y and regression coefficient between new variables u and v are same. So we can write down, we can obtain the formula for bvu by replacing x and y by u and v in this formula, and because we are taking this change of origin, calculations in terms of u and v will be smaller as compared to calculations in terms of x and y. So here we are going to use this form of straight line, y minus y bar equal to byx times x minus x bar, but this byx will be obtained by considering this change of origin. So we will find out, first we will find out appropriate values of a and b, and then we will find out regression coefficient between v and u, that will be exactly equal to this one. So here I have written that regression coefficients are independent of change of origin. Suppose given variables are x and y, and we define new variables u and v by u equal to x minus a and v equal to y minus b, where a and b are constants which we generally call as assumed mean, then byx is always equal to bvu and bxy equal to buv. Byx can be obtained by this formula, byx equal to bvu, that will be given by n times sigma uv minus sigma u sigma v divided by n times sigma u square minus sigma u whole square. This formula is same as this formula. We are just replacing x by u and y by v. And regression coefficient bxy will be obtained by this little change. Here we are dividing by n times sigma u square minus sigma u whole square. Here we will divide by n times sigma v square minus sigma v whole square. This denominator remains same in both the formulas, n sigma uv minus sigma u into sigma v. Here we consider u because second suffix is u. Here we consider v because second suffix is v. Line of regression of y on x is then given by y minus y bar equal to byx times x minus x bar, that is y minus y bar equal to byx will be replaced by bvu times x minus x bar. Similarly, regression line of x on y is x minus x bar equal to bxy times y minus y bar. Therefore, x minus x bar equal to regression coefficient between u and v times y minus y bar. Now, to use these two formulas, we will require all these things. First, we have to select values of a and b. A we will select any value from given values of x, b we will select from values of y. After that, we will find out u and v using these two formulas, and then we will find out all these summations, sigma u into v, sigma u square, sigma u, sigma v, all these things we have to find out. Here total number of points are 7, so we have written that n equal to 7. Now we denote this variable cells by x, that is number of tablets, and advertising expenditure in rupees is denoted by y. Now out of these values of x, we can take any value of x as capital A, but we consider this middle value as capital A, and similarly we consider b equal to 20, and we take this substitution u equal to x minus 300, v equal to y minus 20. Then we know that byx will be equal to bvu and bxy will be equal to buv, and here we have to find out two lines of regression. So we will require these two quantities, bvu, that is coefficient of v on u and coefficient of u on v. So we will require sigma v square also. We will require sigma u into v, then sigma u square, sigma v square, and sigma u and sigma v we will obtain by summing values of u and v. So first column will be for u, second column for v, third column for product of u and v, then square of u and square of v. So I have prepared table according to that. Here I have written values of x and y, then u is obtained by subtracting 300 from each value of x. Similarly, v is obtained by subtracting 20 from each value of y. Then we have taken product of u and v, then square of u values and square of v values. So in this way we have written all these things. You can understand. Suppose I consider x equal to 190 here. I will have u equal to 190 minus 300, that is minus 110. So in that way I have obtained all these values u. Then I subtract 20 from each value of y. For example, if I take y equal to 5, I obtain 5 minus 20, that is minus 15. So in that way we obtain all these v values. Then we multiply these values u and v, and we obtain this column for products u into v. After that we take square of each u value, that is minus 110 square, which is 12,100, and so on. Then we take square of each v value. Now we have made the total for each column. Sigma x is 1925, sigma y is 130, sigma u is minus 175, sigma v is minus 10, sigma u into v is 2850, sigma u square is 19525, and sigma v square is 550. Then we find out regression coefficient of y on x, that is byx equal to bvu, and we have written formula for bvu: n times sigma uv minus sigma u times sigma v divided by n times sigma u square minus sigma u whole square. Sigma u into v is 2850, n is 7, sigma u is minus 175, sigma v is minus 10. Sigma u square is 19525 and sigma u is minus 175. So we substitute all these summations in this formula, and we obtain that regression coefficient is 0.172, and these two are always equal. So we obtain that regression coefficient of y on x is 0.172. Now line of y on x is y minus y bar equal to byx times x minus x bar. So for this we require mean of x and mean of y. So that we can obtain in this way: mean of x is x bar equal to sigma x by n, x bar equal to sigma x was 1925 divided by n, that is 7, which is 275, and mean of y is y bar equal to sigma y by n, sigma y is 130, n is 7, so y bar is 18.571. Or we can obtain this mean in this way also. This we have discussed in the lecture of finding mean by shortcut method. Here we have taken the change of variable, we have taken u equal to x minus a. So x bar will be equal to a plus sigma u by n. A was 300, sigma u is minus 175. So in this way also we can obtain mean of x. So what is benefit of this? We can have here, actually we don't require sigma x anywhere in this formula. So if we are using this formula x bar equal to a plus sigma u by n, then we don't have to calculate sigma x. Sigma x is not required anywhere. So we can use this shortcut formula for mean of x. Similarly, mean of y can be obtained by this shortcut formula b plus sigma v by n. So here also if we use this formula for mean of y, we don't have to calculate sigma y. So that will save our time. If we are using those two shortcut formulas for mean of x and mean of y, we don't have to calculate these two summations, sigma x and sigma y. So once we obtain x bar and y bar, we have this formula for line of regression of y on x. It is y minus y bar equal to byx times x minus x bar. We substitute y bar equal to 18.571. byx we obtained is 0.172 and x bar is 275. So we substitute here, then we multiply this bracket by 0.172. So we obtain 0.172x minus product of these two is 47.3. Then we take this on right hand side and we add these two, and we obtain this line of y on x, y equal to 0.172x minus 28.729. We are asked to find out line of x on y also. So for that we require this regression coefficient, which we can obtain by coefficient between u and v. So regression coefficient of x on y is bxy equal to regression coefficient of u on v, and we remember this formula, n times sigma uv minus sigma u times sigma v. Here we have second suffix v, so we consider these summations corresponding to v, n times sigma v square minus sigma v whole square. Now this quantity is the same quantity in the formula for bvu. Okay, this remains same in both the formulas, and this we have calculated as 18,200, so that we have substituted directly 18,200, and then we write n equal to 7, sigma v square which we have obtained from table is 550, and sigma v is minus 10. So we have substituted sigma v square and sigma v here, and we obtain this summation as 3750, and finally we obtain that regression coefficient of x on y is 4.853. So now we are able to write down the line of regression of x on y, that is x minus x bar equal to bxy times y minus y bar. Bxy is equal to buv, which is 4.853, and we have obtained mean of x and mean of y. So we substitute all these quantities here, and then we multiply this bracket with 4.853, and after that we take this on right hand side, and we obtain this line of regression of x on y. So in this way we can obtain two lines of regression of y on x and x on y. So here we have used these two equations to obtain line of regression of y on x and x on y, and to find out regression coefficients we have used this change of origin. You can imagine if we are not changing the origin, then we will require all these summations. Suppose we are computing byx by direct formula. Direct formula is n times sigma xy minus sigma x times sigma y divided by n times sigma x square minus sigma x whole square. So if we are not applying the change of origin, then all these summations, these products, suppose we are using actual values of x and y, then this summation is going to be very large. Similarly, sigma x into sigma y. Similarly, you can imagine for square of x values, 190 square, 240 square, 250 square. So all these squares are going to be very large. So that is the reason why we are changing the origin. You can compare this x values with u values. U values are minus 110, minus 60, minus 50, 0, 10, 35, 0. So these values are small as compared to x values. Similarly, y values you can compare with original values. In this we obtain 0 also. So if we are changing the origin, then our calculations becomes smaller as compared to actual values. So here that is the reason why we are changing the variables from x, y to u, v. If you wish to apply method of least squares, then also you can do the same problem using method of least squares. Answers will be same. So this is all about this session. Here we have obtained the two lines of regression of x on y and y on x using these two equations, and we can obtain another line simply by replacing y by x and x by y. And we have not used actual values of x and y, we have used that change of variable u equal to x minus a and v equal to y minus b, and we know that regression coefficients are independent of change of origin. So this helps us to minimize our calculations. So this is all about this session. I hope you like it. Thank you.